Hello, my name is Jesus Rodriguez, and I will be doing the rework for midterm one for MAE 131A. So, for question one, it states the correct internal force sign conventions we used in this course are. For this case, I chose the answers A and C because on the right side I have some drawings depicting what the correct sign conventions are. So for positive bending, it'll also show the tension of forces going outwards from the body, and then if it's in negative force, it'll be in compression going towards the body, and as well, the bending force will be going downwards on the edges. So on for A, it shows for the negative sign, so it would be in compression, and then also going downward motion, so that's the bending. And as well for C, it shows positive force. So the force is exerting outside of the body, and then the bending is going upwards. So for part two now, or question two, it says the airplane shown is experiencing excessive wing deflection. Which of the following material properties is critical for this? So since we see that the airplane wings are not like torn apart or they're not necessarily showing any excessive failure other than just a deflection, we can rule out the strengthness only because, as I put right here, stiffness determines the resistance to elasticity. So I did not mean to highlight the D, it should be A, but yeah. So as I stated, the stiffness is too low because it's the wings are getting folded with the movement of the airplane. So now, um, for question three, the yielding occurs, the material, when yielding occurs, the material will, so you can't really see on the right side of the diagram, but I will explain it. So, um, the straight line is a slope line, and that depicts Young's modulus, so the elasticity, and then the point right where it's Young's modulus connecting to the curve, that would be, um, that would be the yield. So, and then right at the top is the maximum strength. And then at the very end, where it ends, that's the ultimate failure. So the maximum strength is when the material reaches its maximum ability to deform. And then the ultimate failure is when it finally gives out after the immense pressure it's experiencing. So the yield, sh when yielding occurs, it should be D, because that is the point right before it starts yielding and where it is going to permanently deform up until maximum strength. Because if it's somewhere within at least the Young's modulus, it can possibly return back to its original state. But once it reaches the yielding, so it says when yielding occurs, it's already past that Young's modulus, so it will continuously deform from here on out until it finally gives out. Okay, for question four, so what loading could generate normal stress? So there's actually two normal stress equations that we've used throughout this course, which is sigma equals NA and sigma equals, yes, so how I stated, sigma equals my over I, which is inertia. So with that being said, it would be answers B and C, because if we look through these, it cannot be H because we are not adding these forces. They are two separate forces. So it would be simply B and C. For this part of the problem, I had a bit of confusion because I am not 100% sure if I'm correct, but we do have